All right. Happy Thursday, everyone. Good morning. Our last session of remote learning. Welcome in. Hopefully, you're all doing well. I wanted to start off today by kind of going over our Spirit Week, our virtual Spirit Week, kind of a flashback to what we talked about a little bit or introduced on Tuesday. So I didn't see you yesterday. I'm sure you were in some of your other blocks, but yesterday was WAG Wednesday. If you wanted to take a picture of yourself and your pet and share it, that was what that was all about. I took a picture, a selfie of my, I'll share that in just 1 second. Today is TV Thursday, so sharing a new favorite movie or TV show. I'll kind of tell you what a couple things I've been watching, and that'll be our Spirit Week, at least my version of it. So you're welcome to share on that as well. And we'll go. Here's a picture of my puppy and I. As I was trying to take a picture with her, she obviously started to try to lick my ear. Me and my little girl for WAG Wednesday. And then for TV Thursday, excuse me, I have Westworld. I've been watching Westworld. Been watching it since the first season, but it's out again, so watching that and amongst of other shows. But it's probably my favorite show I've been watching, other than The Office, of course. And my favorite movie that I've been watching, or that I did watch, something called Brittle Rock. It's a collection of short films for that I like climbing. So that's probably the best movie that I've watched. And I've watched a lot of movies over the course of this last 2 weeks. So that's kind of our virtual ASB thing there. Tomorrow is Fab Friday. What is that all about? Where are your VHS? Maybe I'll take a picture, put it up, or a video I record tomorrow will be in my VHS gear. But if you want to in your classes tomorrow or at some point post it on the VHS Instagram, feel free to do so as well. Does anyone have a selfie that they want to share of them and their puck for WAG Wednesday, or want to share a favorite TV show or movie that they've watched? One Piece. What's that about, Andrew? If you want to, y'all can unmute yourselves too to go over this. Pirates. Nice. Never heard of it. I'm sure it's pretty good. Very cool. Anyone else been watching anything good that they want to shout out and throw a recommendation on? Okay, right on. Then on that note, cool. Let's move on then. So kind of following with shout outs, I know some of y'all have been working hard on your work, but also doing other things on the side. What the heck is going on with doing some other things on the side here, and I just want to shout out to those of you who are taking this opportunity, both academically and also personally. Ran into a student yesterday, maybe not necessarily at our level because y'all can't drive yet, but I ran into a student yesterday who was out shopping and been starting a project with some friends to shop for people who can't get out. So if you've been doing anything that's been bettering yourself and or helping others out in this time of crisis, I want to take it to you. I'll give you a kind of a silent clap, and I do appreciate as much as everyone how hard y'all have been working, both academically and non-academically here. So again, that's kind of a shout out on that. What you now see here on the screen is just kind of some quick comments based on questions I've been receiving. One, let me kind of tackle where I received the questions. A lot of y'all have been filling out these remote learning questionnaires. I've been posting them basically every single session on the Google Classroom. As you may or may not be aware at this point, Google Classroom is basically the best way to get all of this information. Assignment due dates, anything that we do in this class is always on the Google Classroom. If it's on the Google Classroom, I recommend you complete the assignment. If it's not in the Google Classroom, you don't have to do it. So all of the EdPuzzles, all of the assignments, everything that we're doing that you can find on the assignment sheet and all that stuff is always posted on the Google Classroom. That's kind of your best friend. Also, you've been doing a really good job. Algebra 1 specifically, very, very well done, asking a lot of questions. The one I posted on Tuesday, right before recording this, I had 16 different questions posted. Very well done. I'm super stoked that y'all are taking this opportunity to reach out to me. Please feel free to continue to do so via these remote learning questionnaires that I've been posting on Google Forms. They've been a really good job. Okay, back to the slide. You always are welcome to do that and email me, but some of the big questions that I've been getting continuously are about EdPuzzles. So EdPuzzles are equivalent to classwork. They're effectively like in a normal, when we were at school, if we would be completing something in class, the lessons that we were doing and the notes that we were taking, Edpuzzles are basically, so Edpuzzles are not homework. Okay, they're not, they are graded on completion, not necessarily right or wrong. I'm returning the scores to you, right or wrong, so you could see what you missed, and I hopefully am making comments on all of those. But once we complete a unit, which by the way, today's our last lesson on transformations, right on, I know some of you might be stoked on that. I'm gonna go through and then take all of the Edpuzzles that were completed and then put them into the gradebook, Infinite Campus that is, for completion and participation. Okay, so I recommend doing Edpuzzles because they will help your grade if you complete them, regardless if you whether you get every single problem right or every single problem wrong. It is a completion grade. Also, it helps us, or the goal of them is to help us, together with these lessons, understand the material a little bit better. Now, I understand that this whole learning process, remote learning, is a little bit more difficult, not necessarily as ideal as our traditional based school learning. So I kind of shout out to y'all on your effort and my appreciation for your effort this far. I mentioned earlier, follow the Google Classroom. It has all the assignment due dates on it, all the assignments you need to do, and all the links. But that is your best friend when it comes to the figuring out what we need to do. Also, the remote learning agenda, which looks a little something like this. This is also up on the Google Classroom. This is, again, a handout or a online handout that allows you to know exactly what we're doing every single day. Today is the 26th. So today we're going to be doing a transformation review, finishing up the section, and we'll be doing so by talking about that review handout, okay? So this, together with assignment sheets, the ones that we always worked with before. Hold on a second, I didn't have this one loaded up. And the Google Classroom are your best friends, and by assignment sheets, I mean these things. They're still accessible, they're still up, and they're all fully updated to take into consideration our remote learning situation. I made all the updates in red. All right. But again, the reason why I was talking about how hard y'all have been working, and I want to let you know that when you're logging onto these and I can see who's here and I can see who's participating and taking these things into consideration, I will reciprocate that when we go into grades at the end of the year, okay? So third quarter grades have already been posted. That was basically, I graded you, or everything we did before remote learning, okay? Everything from here on out, just do your best, kind of participate as much as you can, join these sessions, and I guarantee you, I will remember your hard work when the grading process comes down. I know how hard it is to learn math remotely online, so I will take that into consideration when I am grading things, okay? I do promise you that. Just do your best, and if at the end of this you put this online learning, then that's really all that we can ask as teachers and administrators have linked to campus, okay? So kind of just an encouragement there to try your hardest and do your best to continue on this process. All right, before we get into today's lesson, does anyone have any specific questions about all the information I just threw at you in rapid fire flow? If you have a question, unmute yourself. Hey, say, hey, Mr. B, and then go ahead and ask it. Right on, cool. Okay, so I think we're getting the hang of the remote learning questionnaire too, so feel free to fill those out. I do appreciate that so much. All right, last but not least, that's what we did yesterday. Today we are finishing the transformations unit. We're done talking about graphing for a little bit, at least in terms of parent graphs and transformations, for a little bit after today. So because of that, we're going to review the transformations unit, which is on parent graphs, the A, the H, and the K, shifts up and down, side to side, and the stretches and reflections. And we're also going to go over the descriptions, the increasing, decreasing interval, and we're going to try to do that all through the use of a handout that looks a little something like this. Okay. So this is our transformation review handout. This is an assignment. It is located on your Google Classroom. It is also, boom, right here on our assignment sheet. This is the review one, okay? And it will also be located on our learning agenda. So as it looks back up, this is this transformations review handout that you see right there for today. This is the heavy hitting problem of this. It's due April 15th. This is what it looks like, okay? Morning, AJ. I canceled one of them, and the one that I canceled looks like this. Y'all can see that on the screen? You're still welcome to do it. You don't need to turn this in, okay? This is the one that if you look on the assignment sheet, it says canceled due to remote learning, okay? That's this one right here. Canceled. Don't do it. You don't need to do it. I handed it out to you on the last day before remote learning. You don't need to do it. You need to do this one, okay? Right on. All right, then on that note, let's do some problems. Let's start off on number 2. Okay, so here's today's lesson. We know we're going to go about anywhere between 10 to 20 minutes on it. If you already did it, well done. Make sure you upload it to the Google Classroom. I believe I already saw that one. So yeah, good job, Andrew. It is not a page, it is a handout. So it's not in the textbook. It's something that I gave to y'all the Friday before on our Almost Pi Day. I know not all of y'all were on campus on Almost Pi Day. So I have made this available on the Google Classroom as well. Do we all know how to navigate the Google Classroom to get to it? I have a hunch that might be a no, so let's talk about it real quick. You see on again, this right here, this Google Classroom is the app version on my iPad, so it might look a little bit different on a browser. But effectively what I'm going to do is at the bottom middle of my screen, you'll see classwork. It's probably in the top middle of your laptop or computer screen, just because it's not an app. But I'm going to go to classwork, and then I'm going to go to module 6, which, sorry, as mine loads, it's a little behind the times here. Really behind the times here, obviously, because you could see it loading for so long. Cool. So module 3, excuse me, module 6 is for Algebra 2 Trig. So module 3 here, notice all these old lessons. Those are all old assignments. You see the one that says Transformations Review Handout? I'm going to click on it. And then what you could do here is go to instructions, click on this PDF. Boom, right there. Right there, right there. Okay, so not a page in the textbook, but rather a handout accessible through the Google Classroom and also the Google Classroom stream. All right. Cool, let's do number 2 then. And if you don't have this printed out right now, I would just recommend using a separate sheet of paper and then transposing it. Remember, how you're submitting things is by taking pictures, so you could realistically do everything on a separate sheet of paper and then take a picture of it and send it to me. So here's number 2. All right, problem time, let's go. Okay, so we want to give the name of the parent function of this f of x function, and we're going to talk about what the parent function is, and then I'm going to actually work to graph this right here on number 2 directly off there. So f of x is our transform function here, and our parent function, I'm just going to call it g of x. Okay, it's just a different function name. Our parent function is the absolute value function, the absolute value of x. Keep in mind that parent functions are always the simplest. They have no addition, subtraction, multiplication attached to it there. So the reason why I know that this parent function is g of x, or absolute value of x, more accurately said, is because they have absolute value signs, and there's an x there, okay? So that is our absolute value parent function, and I'm going to graph this. You don't need to do this if you don't want to when you're graphing, but I'm going to graph the absolute value of x right here. And the absolute value of x, let's just call it y equals absolute value of x so it's easy to see, can always be graphed, and we can always graph anything by using a function table. So I'm going to pick some real quick, easy values of x. We're going to do this rapid fire, okay? So if y is equal to the absolute value of x, well then, I can say y is equal to the absolute value of -2, because notice I plugged in -2 in for x. And we know that an absolute value, and some of you did a fantastic job on your Edpuzzles, kind of reiterating this point, but an absolute value always makes anything on the inside positive, so the positive form of -2 is +2. Next up, y is equal to the absolute value of x when x is -1. The absolute value of -1 is +1. I'm just going to cruise through this real quick. Y is equal to the absolute value of x, but now x is what? 0. So absolute value of 0 is just 0, because 0 is neither positive nor negative. I think you're getting the idea, but I'll finish it off real quick. Absolute value of 1 is 1. and y is equal to the absolute value of 2, because now x is 2, and that's 2. All right, work gone, because I'm going to need to clear up that space in a second. But now what I have is I have a bunch of ordered pairs. Ready? -2, 2. -1, 1. 0, 0, 1, 1, 2, and 2. So I'm going to graph those 5 pairs. -2, 2. 2 to the left, 2 up. -1, 1. 1 to the left, 1 up. 0, 0. Right there on our origin. We know that most parent functions go through that origin. Flash back to that absolute value, that parent function wrap. I know we all missed that. 1 over 1 up and 2 over 2 up. Here is our absolute value parent function in blue. Rough sketch of it. Right on. Kind of mirrors what we expected, that V shape. It looks a little something like that. Boom. Okay, the reason why I graphed this here and I did it fast, actually, hold on, let me put that back up for 1 second, is because I'm going to graph this new function, which I'll graph in, say, green here. I'm going to graph this new function by looking at only its transformations. So what's going on here? How is this f of x different from the g of x? Well, it has this 2 in front, and it has this 1 right there, okay? It has this 2 in front, it has this 1 right there. So what does that 2 do? That 2 is our a value. And if a is 2, that means that we're going to have a vertical stretch of 2. And really what that vertical stretch by 2 really means is that it's going to be twice as tall as it used to be. Like imagine taking me and vertically stretching me twice as tall. I'd get a lot skinnier naturally, but I would also get way, way taller, get twice as tall as I am. I'd be like 12 feet tall. So when we have an a value of 2, it vertically is making it twice as tall. It's stretching it up. Okay. Now what is this 1 right here? That's our h value. H is 1, because remember it presets at x minus h. So that h value is really the 1 right there. And that means that we are doing a shift to the right 1, because it's a positive 1. Shift right by 1 unit. Cool. So now all I'm going to do is I'm going to take every single one of these points, the 5 that I already graphed, and notice I already have 5 points right there. Let me highlight them again, nice and dark. That point, all of these points, and I'm going to execute what I just said to do. I'm going to make them, I'm going to shift them to the right 1 unit, and then I'm going to stretch them up twice as tall. So here we go. Shifting to the right 1 unit. Start at the origin. Ready? Goes over there. So I shifted it to the right 1 unit. Nice. And now I'm going to double its height. What is twice 0? 0. So if it's at a height of 0, it doesn't matter if you double it up, it's still going to be at a height of 0. All right, next point right here. Shift it to the right 1 unit. So now it moves over to the right 1 unit. And now I'm going to double its height. Right now, what is the height of this thing at? This thing is at a height of 1. So if I double it up, it's really now going to be at a height of 2. Okay. Last point here, ready? It's kind of hidden, but this blue one is underneath it. So I'm going to shift it to the right 1 unit. Again, I'm shifting this blue one down there, because that was one of the original points. I shifted it to the right 1 unit, because that's what my h value told me to do. And then I'm going to double up my height from where it's at now. Where is it at right now? It's at a height of 2 units. So what's 2 times 2? Well, now I'm going to go to a height of 4. Boom, right up there. So all that I did, y'all, is I took every single point, highlighted in, let's go highlighted in pink right now. I took all of these pink points. I shifted them to the right 1 unit and then made them twice as tall. Shifted them to the right 1 unit, made it twice as tall. And now I can connect my dots.
Have 2 cameras? He like got 2 angles of himself. I'm confused.
What's up, AJ?
He's like 2 cam. Okay, never mind. He turned it off. But like it was like forward, and then he had 1 to the side. It was confusing the hell out of me.
Me?
I got confused for a second. It was really weird.
You're talking about AJ?
Andrew.
No, it was
Andrew.
Gotcha.
Andrew had like 2 computers like showing the video, and it confused me for a second.
He's like mirroring himself, huh? Strange. All right. So let's do it real quick. Ready? Shift to the right 1 more unit, each of these points. So I'm going to shift to this left side to the right 1 unit. Again, notice I'm just taking each point, this one now, and I'm moving it to the right 1 because our h was 1. When I move it to the right 1, it's boom, now here. And I'm going to double up its height, which takes me to a point up here. Twice 1 is 2. Cool. Last point. Ready? Shift to the right 1 unit. Boom. Now it's there. Double its height. Well, what's its height at right now? 2. What is twice 2? 4. Guess what? Now we have the ability to see our stretched transform function. F of x is this green function where it's been shifted to the right 1 unit, hence why you notice the whole thing is over to the right of where it used to be. And then it's looking skinnier because we vertically stretched it, and when you vertically stretch something, it also brings it in and shrinks it in. As we continue to expand this out, this will be twice as tall at any given x value than it previously was. I'm going to shifted, moved it to the right 1 unit and vertically stretched it. There's number 2. Notice I did that without even using a function table. I only used our knowledge of A and H there. Right on. Let's cruise. Here we go. To number, by the way, you notice number 3 and number 4 are done right there. Those have separate videos on the YouTube channel. Reference them. Check them out because I highly doubt you're going to be able to get those all done right here. They have, again, separate videos. Okay, number 7. Okay, see if we can do this pretty rapid fire. Does anyone know what the parent function is? If you do, yell it out.
Mr. Redham?
Yes.
Can you scroll back up to the 2 problems real quick?
No.
Which problems?
No, Mr. Venom, stay where you are. It's good. That's her fault for not.
AJ, hold on. I'm gonna leave it on this screen for like 15 seconds because numbers 3 and 4 actually have separate videos on them already. So
I know, I just wanted to take a picture. I didn't want to copy it.
Gotcha. Okay, right on. After that, sorry, I think my screen got messed up. Are you good with the picture? Cool.
Yeah, sorry.
Yeah, no worries. All right, I'm gonna move back down then. Okay, cool. Number 7. I'm gonna graph the parent function in black. Does anyone know what the parent function of this is? We'll just call it y for ease of understanding x and y values. Yeah, good call, Andrew. It is a quadratic. Here's our quadratic function, y equals x squared. Andrew basically extracted that x squared, brought it on down. By the way, starting next week, we're learning all about those things. So great call, dude. Y equals x squared is our parent function. Here's what it looks like. And I'm going to tell you how I got those points real fast. Ready? Rapid fire form. Y equals x squared. We can always graph anything with a what? I'm hearing echoes of the past. Function table, there we go. So I pick my favorite numbers. Y'all know them by now. -2 to +2. I plug them in to get y. So when x is -2, I just dropped in -2 for x right there. Where'd I get that from? The values I chose. -2 squared is the same thing as -2 times -2, and -2 times -2 is +4. When x is -1, we go -1 squared. -1 times -1 is +1. When x is 0, y would equal to 0 squared. You get the idea. Boom. Okay, a little substitution and then PEMDAS is really all that we need to graph anything with a function table. Works 100% of the time. Now, all of these points, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4, boom. Already graphed right over there to make this quadratic our upward-facing parabola, as we'll soon come to know it. Now I'm going to connect these dots, 0, 0 to 1, 1 to 2, 4, 0, 0 to -1, 1 to -2, 4, boom. Okay, so that's how I got all those points. Function table. That is our parent function. Now the reason why I did this is because we're going to graph our new one, h of x. Sure, we'll do it in pink in a second. We're going to graph our new h of x function by just using the transformations. So what's going on? What makes h of x different than y equals x squared, our parent function? Well, two things. There's a negative in front, and there's a +1. And notice that this +1 is not attached to the x, okay? It is not contained within the x squared. So really what that means is that this is my k value, and that is my a value. So my a value is negative, aka -1, and that means that we're just going to reflect. And in this case, that means we're going to open down. Since it's negative, we're opening downwards like a sad face. You got a negative demeanor, you got a negative parabola, downward facing parabola, like a frown. Okay, cool. And my k value is +1. So when k is 1, what does that mean that we're going to do? Ridiculous equal sign. That means we're going to shift up 1 or move up 1. Cool. So I'm going to take every single point, all 5 of them, and there are 5 points. Ready? Here they are. Vertex 1, 1, 2, 4, -1, 1, -2, 4, and I'm going to reflect them and shift them. Reflect them and shift them. Okay, so let's reflect first. We'll learn more a little bit about that when we get to Algebra 2, why we reflect first. It's basically order of ops. But I'm going to reflect each point first, okay? So let's reflect this point right here. If I reflect it across the x-axis, that means this is my mirror. So the real question is, when you are reflecting something, like I'm being reflected on this video right now, the closer I get to the camera, the closer I look, the farther away I get to the camera, the farther I'm looking, because the camera reflects me. So when I reflect this over my mirror, the x-axis, what I'm really looking for is how far away is this point from the mirror? And the answer to that is, this point is 4 units up. So I'm going to reflect it by moving in the opposite direction, 4 units down. So when I reflect, one more time, when I reflect this point right here, it's going to now drop same horizontal location, just 4 units down, right about there. Okay, there's my reflection. Now I'm going to reflect, I'm just going to do all my reflections first. How about that? Let's reflect this one. Well, it's 1 unit up, so reflecting over makes it 1 unit down. Can I reflect something that's right on the mirror? No, it stays on the mirror. Okay, 1 unit up, 1 unit down. Here's my last one, 4 units up, 4 units down. Sweet. Do we all feel comfortable how I turned this into a downward facing parabola by reflection? Sweet, okay, cool. That means that my reflection is done. Now all I got to do is shift all of those 1 units up. Hey, great call, Andrew. I didn't see that comment until now, but you're 100% correct with our transformations. Reflect and shift. So let's move every single one of these points 1 unit up. Ready? Up 1, up 1, up 1, up 1, and up 1. I moved all of those green reflected points 1 unit up because our K was 1. See ya, greens. Here's our parent function again because I accidentally erased it. And now here is our new transformed function that got reflected and then shifted. Boom, h of x graphed. Again, 100% of the time, you could totally graph h of x by using a function table and picking values of x and plugging them in. That's just substitution in PEMDAS at that point. But for sake of time, I'm going to continue to work on down unless I have any specific questions on number 7. By the way, if you Lady asked for number 3 and 4. So if you notice when I left it up here for 3 and 4, we've done 2, 3, and 4 and number 7 already. So this review problem is going to be, or this review handout is starting to slowly manifest or be worked its way out for y'all. So always feel free to continue to ask more questions, okay, if you need me to do a specific video on like number 8 or number 1 or something like that. All right, I believe my last problem that I wanted to do today was, let's do number 11. Okay, let's do number 11 here. And what we're doing on number 11 is we're given a parent function. So the parent function on number 11 is the absolute value function. And what that means is, we'll just call it f of x for function notation. Oh no, they want f of x to be the transform notation. So we'll call parent function g of x. And this is our parent function, the absolute value of x. Now, what they want us to do is they want us to write a description of the transformation. So our new function is going to be f of x. And they want us to basically take into consideration that we shifted it up 5 and to the right 3. So let's think about what that means. If we know that this is an absolute value function, it's going to be something like such. And I know that there's going to be some sort of a h, let's actually not do that in blue, h and k possibility here. The colors are all off right now. Let's go orange. Again, what we see here in this multicolored situation is our transformation function, where we took the parent function of the absolute value, f of x equals absolute value of x, and we are now going to potentially shift it up, down, side to side, stretch, or reflect it based on that a value. But it just so happens that in this case, they only give us 2 transformations to do. They want us to vertically shift it up and horizontally shift it right. So vertically shifting it up is going to be our k value. So that means our k is 5 because it's going up 5, so it's positive 5. And a horizontal shift right means that that's going to be our h value. And since it's moving to the right, that means h is going to be positive 3. So now what we have here, Andrew, good job, man. Andrew already gave us the equation, by the way. If you look at the chat, is that g of x, we can plug in pop. What we know is that h is 3 because of a shift to the right 3, and our k is 5, positive 5. So I'm going to replace that k with 5. Were we given anything about a reflection or a stretch? No. So a is just gone. It's 1 effectively. I think my connection's a little slow right now, so you might be seeing some sort of lag. But if you check the chat and now our final product, what Andrew wrote and what I wrote are the final product. This is our parent function with a shift to the right 3 and a shift up 5. Nice done, Andrew. Nicely done, Andrew. All right, that's number 11. So let me put my iPad down here real quick. We have a little bit smaller of a class here today. It looks like some people might either be busy or lost motivation. So I want to motivate y'all to continue to engage in these lessons. Okay, just keep that in mind. Y'all do your best that you can in this process to try to get to these. But y'all know that these are recorded anyway, so you can check on the YouTube channel if you miss them. But does anyone have any other specific questions that you want me to kind of address, either about the class or about a specific problem right now, as we have about 11 minutes?
No, I feel good.
I will definitely post this for sure. Yeah, I'm going to post this like basically right after we get done with this lesson. First thing I'm going to do is I'm going to convert this file, and then I'm going to upload it to YouTube, and then I'm going to go make lunch. So before I even eat lunch, this thing will be on YouTube. Okay, guaranteed. Zaid, you're good, you said?
Yep.
Right on. I'm glad to hear that, man. Anyone else have a specific question? Thank you, Avery. I appreciate that. Have a specific question about any of these problems? You want me to do any one on this page or any other problem moving forward? Do we all feel comfortable with what the ed puzzles are? What's expected of us on those? Do we all feel comfortable?
Have you posted a new one yet?
I have not. I posted
Okay.
this morning a Kahoot, and by the way, the Kahoot that I posted is just supplementary. It's actually one that y'all already did. We did it in class together. So if you do the Kahoot that just posted, then you've seen it before. Zaid, to answer your question a little bit more in detail, I will be posting another ed puzzle next week. Until then,
Okay.
just try to focus on getting all the ones that are already up posted, because next week we start a whole new unit. Okay? Great
All
question.
right.
Can you do problem 12?
Problem 12, definitely. Okay, number 12. Cool. So we have a linear function. So I'm going to move this k equals 5 a little bit up out of the way so it's easier to read. Okay. So what we know here is we have a linear function, which means my parent function is going to be, I'm just going to use g of x as a name tag right now. Remember, just supplementary to y. G of x equals x. That's our standard parent function for lines, y equals x. Okay. Andrew, I'm going to get to your question right after I do this problem. Okay, so I see it on the chat. So what we know is that we have a vertical stretch / compression by 2/5. And the reason why they call this a stretch / compression is because the fraction is less than 1. 2/5 is smaller than 1. So really it's stretching it by something smaller than 1, which is actually like shrinking it vertically. So a lot of y'all on the Edpuzzle, there was a specific problem on transformations that asked what does the A value or the value on front do? And y'all told me it tells how steep it is. That's 100% correct. So what that means is the following. This compression by 2/5, that's really a fancy way for linear equations of talking about our slope. It's going to make it 2/5 as tall as it used to be. So our A value is 2/5. So really, the linear equations are actually a little bit more in line with what we thought of lines before. That's just going to be our slope. I know it's kind of weird because we use the variable m for slope most of the times, but slope and verticality, steepness, are truly the same thing. So if we have a line, y equals x or f of x equals x, and we vertically shrink it by 2/5, that just makes it less steep. Instead of being up here, we now shrink it down, which means our A value is just 2/5 in front there. Notice there is no shift to the right or to the left, so there's no plus after the x, and there's no vertical shift. So there's no B value, as we called it, a slope-intercept form. That's just our equation for number 12.
Okay, thank you.
You're welcome. Andrew, let me read your question here. Since there's a chance we are not going back to school for the rest of the school year, how will the final work, or actually the rest of the class? That's a fantastic question. So there is a chance that we will not be together in class before the school year is over, which honestly brings a little tear to my eye because I do miss hanging out with y'all every day. But if that is the case, what I have planned in front of you on the agenda is up through May 5th. We know there's about another month after that. So once I get the official word from the district that we will not be continuing school, if that does happen, I will obviously update this for the rest of the school year. We'll give you a pacing of what we're going to do. And effectively, what I would really focus on as an educator in this situation is I would really try to limit the amount of new material that I would give y'all. And I would really focus on the last like 3 weeks specifically reviewing old material through probably a bunch of online activities and or a few assignments that I create. Okay, so as for the final, to be determined, because I haven't really thought of an effective way to assess the whole semester's worth of material online for a variety of reasons. What I'm kind of contemplating or hypothesizing about doing is doing a project. Okay, but again, that is kind of up in the air right now, to be determined more. And once that information gets passed along, like the second I hear we're not going to be going over new material or we won't be back in class for the rest of the year, then I'm like full force into trying to figure all that out, okay? But until then, we're going to kind of flow with this agenda and work from there. But that's a fantastic question, Andrew. Thank you for asking. I think Sophia asked that same thing last class. So hopefully, Sophia, if you're here or if you're watching this online, that can also give you some more information to answer your question from last session. Right on. Cool. We have about 5 more minutes left of class. Does anyone else have any other questions, either about how we're moving or any specific problem?
Mr. B, are we gonna for when you want us to turn in the book homework on April 3rd, do you want us to take a picture of like every page in the book and add it?
I'm gonna kind of zoom in on your question there. I would take a picture of every page that applies to the assignment.
Oh yeah.
You get what I'm saying. But yeah, if you meant like every page that applies for the assignment, 100%.
Okay.
So how about we do this? I'm going to give you an example of a really good, and this is going to be from an Algebra 2 class, okay? So not putting no one's work is popping up, but some really good examples of students who have turned in work in Algebra 2. And I know some of you have already done this, so a lot of good work being turned in thus far on your end. But like, let's go to here. Okay, so this is how one person in Algebra 2 did it. She did a fantastic job. And what she did is she took a picture, as you can see, of her homework. And to make it even easier on me, which makes me so happy, is that she basically took each picture and put it into a a Google document. So that way all I have to do is scroll down the pages on the document and voila, they can see all that work crystal clear. Y'all see what I'm saying?
Yeah.
That's like a dream come true for me because there are other ways of doing this. And like this person took a picture, and I love this as well. Super easy for me to grade. You know, she took a picture of her work. I can zoom in on it. I can see what she's doing with her logarithms. And then each one of these is I'm scrolling from left to right now because these are each different attachments in PDF form. But notice she attached them all to her upload, and it was basically just 4 different pictures that she uploaded into this one submission. And as I pop back out, you can see here on the right, you notice how there's 4 PDFs in there that she's uploaded. Does that kind of make sense?
Yeah.
Y'all see that?
Yeah.
So she did a great job as well. So I would love any of those submissions like that. Okay. Does that kind of answer your question, Zaid?
Yeah.
Yeah, that's a great question, dude. Okay. Any other specific questions? If not, I'm going to say have a great day and enjoy your weekend. I will be available tomorrow from office hours for y'all from 10 to 11 a.m., at which point I will open up a Google chat. It's going to be a chat box. If you need to speak with me or see me on a video chat, I will open up a video chat, a Zoom session at that point. But tomorrow from 10 to 11 a.m., morning, not night, Google chat if you need to ask me questions. Always feel free to email me. Always feel free to plug in or turn in those RLQs. I just posted a new one to Google Classroom literally right now. And that's those Google Forms that some of y'all have been filling out. Okay, so again, good work, everyone. I appreciate y'all being here. Jeff, thank you. You have a great day as well. And if I don't see you or speak with you between now and the weekend, I hope y'all have a safe, productive weekend, okay? All right, everybody. Bye, y'all. Have a great
Bye.
day. Stay safe. Stay healthy.